In this video, we're going to begin a special 3-part mini-series about the last major topic before we plunge into LINQ. So we're going to be talking about lambda expressions. And if you're planning on using LINQ a lot, then you're definitely going to be writing a lot of lambda expressions. But lambda expressions, not an easy topic to just jump into. We need to build some major background on this before we get into it. So the best way to talk about this is to kind of walk through a sequence of events that lead up to lambda expressions so that it makes more sense. Before I get too far, I want to say that I'm probably crazy for even broaching this topic. I mean, this is some pretty heavy stuff that I'm about to lay on you. In fact, if this is indeed just your 9th day of working with C#, I would be shocked that you could make heads or tails of what I'm about to say. And even if you could understand it, I don't think that you could do anything meaningful with it in and of itself. But if you're not at least exposed to this idea, then there's going to be some syntax that you're going to see that, quite frankly, will befuddle you. And I don't want that either. So please do this. I want you to just listen to what I'm about to say for the next 3 videos. And simply watch the progression of thought. This isn't something that somebody with 9 days under their belt should be able to grasp immediately. I'm presenting this as a means to an end. After I present it, I hope that you mostly forget the details about it for now, avoid getting discouraged, and just know that when we get to LINQ in the next 2 or 3 videos from now, that we're going to build on top of this. And that is what you'll ultimately want to have, in your bag of tricks. The end result is that little tidbits of code shouldn't surprise you that look like this. These are lambda expressions, like O and then an arrow, O dot first name. What does that mean? Or this, O, then that little arrow with an equal sign and a greater than sign, O dot order date. Or this, O, arrow, O, greater than 100. What do those mean? Well, we're going to use that basic syntax throughout the remainder of day 9 and day 10. So the job of this video and the 2 that follow it are to explain what that means. Again, if you find yourself getting discouraged or just blown away, then just stop watching the video for now and come back to it a year from now. You don't really have to know this. You seriously don't need to know everything I'm going to present right now in order for you to be productive. So I just want to give you this as a background. Okay, so let me start off the topic of lambda expressions by talking about delegates. And so before we even get to delegates, let me just set up a simple scenario here. As you can see on our screen, we have a project called Delegates Part 1. And it's pretty simple. We have an array of strings with a list of names. And what I want to do is loop through each of those and find out those that start with the letter A. And then I'm going to add them to a list of strings called strings A. And then I'll just print those out. So basically, I'm just looking for all the names here that start with the letter A. And this is a pretty lengthy syntax, but, it gets the job done. So let's run the application. You can see from that list of names, it pulls out 3 names that start with the letter A. Great. Well, this is something your boss asked you to do. I don't know. And he comes back later and says, hey, that's great, but I need some more functionality in it. I need you to, I need you to build an application so that it will allow you to find all the names that end with N, and I need it to be configurable at runtime. So if the user says that he wants to see all that start with the letter A or letter B, or they end with the letter N or end with the letter S, whatever, you need to create a console application that'll do that. All right, so I've already built this, and I'm just going to paste in this code here. First of all, to accomplish this, I decide I don't really want to keep all of that code in here. I mean, I could do all of this with a big if statement. If the user says this, then that. If the user says that, then do this other thing. Instead, what I'm going to do is just kind of delegate those operations to 2 methods: get strings beginning with and get strings ending with. All right, and they're both going to return a list of strings. And then what I'll need to do is change out this code right here. And I guess what I'll do is just highlight all of this and then comment it all out. And then below it, I'm going to paste in some new code. Okay, so let's take a look at what this does. In fact, let's just run the application first to make sure it works and to see how it works. Okay, so a simple console application. What do you want to do? Press 1 to choose a beginning letter, or 2 to choose an ending character. Let's choose 2, and then let's select the letter N. And so we see that there are 2 names from our list of strings that end with the letter N. Okay, so I could run it again, and I'm going to choose 1, begin, and I'm going to start with the letter B, and it brings back Bob and Bill. Okay, great. So how did I do this? Really simple. This part should make a lot of sense to you. I'm just gathering up which choice and which letter. And now I'm going to do an if-else statement. If they choose 1, then I'm going to call get strings beginning with, and if they say 2, then I'm going to call get strings ending with. I'm going to pass in the array of strings, and I'm going to pass in whichever letter that they chose in that second step right here. And then I delegate the actual work to these helper methods. You can see here I'm simply kind of doing the exact same algorithm that I did before, except this time using, you know, the appropriate ends with for this second function, get strings ending with. And here I'm using the starts with method. Okay. So that's all well and good. But you know, you think, well, there might be a better way to write this application. Now, I'm going to admit up front that for this pithy example, this might be overkill to accomplish the same end. However, it is a way for us to demonstrate the notion of what a delegate really is. And so a delegate is just basically a block of code that you can pass around just like you would a value or an object. Just like every other type, you define the type and then you create an instance of it, and then you can use it in code. So let's use a delegate now to solve this same problem that we just had. First of all, we're gonna define a delegate, just like we would define a class or even declare a variable. So we're going to create a delegate that returns a type bool, and its name is function for string, and it defines also an input parameter, a type. Okay, so this is defining behind the scenes a class called function for string. So the next step is that we're going to create a number of instances of that delegate. So if I scroll down here, you can see here I create an instance of that delegate that I'm calling starts with A, and you might see that this looks awfully familiar to what we saw in the previous example in the delegates part 1. In delegates part 2, we're just going to evaluate one string at a time and return whether this value starts with the letter A or not. Whatever's passed in, does it start with the letter A, true or false, returned as a bool. Now, there's nothing here in this definition of this method that ties it to this delegate definition, but since they return a bool and they accept a string value, this is essentially an instance of that delegate. It can be used wherever that delegate is accepted. It's kind of like an interface in that regard. Okay, so now that we've got our delegate defined up here and we've created an instance of that delegate method here, now I can pass this little method around like a variable or like an object into methods and get it as, use it in that regard, and we'll see how that's used in just a moment. In this particular example, I've created a method called perform operation on string array, and notice that as the second input parameter, it will accept a function. So we want you to perform an operation on an array of strings, so you pass in some strings, and whatever operation it is, well, that's defined by also the function you pass into it. Okay, so we're passing a method into a method. Okay, and then we're going to apply my function against every single string in the array that was passed in. If when running that function it returns a true, then I'll take that particular string value and add it to my list and then return that list back to the calling method. In this case, we'll see down here in static void main. Here I create my strings just like I did in the previous example. And now I'm going to call this perform operation on string array. I'm going to pass in my strings. And I'm also going to pass in the name of the method that matches my delegate definition. Starts with A. And then I'm going to get back a list of strings that start with the letter A, and I'll print each of those out to the console window. Let's run the application. And you can see it accomplishes the exact same thing. Now, admittedly, we're going a really far distance here to accomplish the same thing. But now, think about how easy it would be to just do an ends with. So, off the top of my head, I'm just going to go ahead and type this in. Bool ends with N. Or I can make that variable too. I'm just going to go ahead and hard code it to the letter N. So return s dot ends with N. And then all I got to do now, let's copy this, paste it there. Ends with N. Strings N. Strings N. And then I'm going to run it. Okay, and so as easy as that, I was able to add a whole new chunk of functionality to the application by just creating another method that matches the delegate signature that I'm accepting into this method. So I'm passing in that method to be evaluated against all of the strings, just like I did in the previous example. Okay, so it's a way to make your application more flexible and extensible by providing this little chunk of code that can be passed in, a block of code that can be passed into another block of code and use it as an evaluation. All right, so there's really 4 steps to this process. First of all, we define the function type, which we did right here. The second, and basically what am I doing there? I'm defining how many input parameters and what the return type is. Then secondly, I create one or more instances of that delegate, like we did with the starts A method or the ends with N method. All right, then I can start using that type, that function type, that delegate. You can use it to define an input parameter, like we did here in this method. Now I can start passing in an instance of the delegate, our starts with A method, for example, or the ends with N method for that matter. And I can pass it in to this perform operation on string array and trust that it will use that in its algorithm to determine whether to add that particular string in the string array to the list that's returned back to our static void main. Okay, so just think of delegates as classes, but instead of defining a data structure, you're defining a method. Or even think of it as an interface. You're defining what will satisfy that particular delegate definition. All right, so why do delegates exist? What purpose do they serve? Well, they allow you to delegate an action or a decision, or in this case, an algorithm, to a method that can be passed around and used as an input parameter to a larger method. So it allows a method, in this case, perform operation on string array, it allows it to be configurable. You can configure a method by passing in another method that'll handle some small piece of the puzzle. You're delegating that part of the process to some other method. And so clearly, again, in this example, you could achieve the same outcome by using a simpler approach. However, a better example might be a sorting algorithm that works for any data type, including integers or orders, like our order class that we've been using. In fact, I have such an example already in the oven. So I have this third example called bubble sort, and a bubble sort is a well-known algorithm. It's recreated in every language as an example of how to sort a list of items. And so the algorithm to me is not as interesting. We can scroll down to the very bottom and see this class that I created called bubble sort, and it has a single static public method called sort. And the way that it works is it just compares one value against the next, and it keeps going until it's kind of copied and repositioned everything into the proper order based on whatever criteria you give it, and then it'll return back to you a list sorted in that order. All right, so you can look at this algorithm. Again, what's interesting about that algorithm is really the only part, I think, for our purposes, is the delegate that we're going to pass into it and tell it for this given type, whether it's an integer or an order or an employee, sort by this criteria. So we're going to show you how to do that part of it. Let's back up to the very top. The first thing that I do in my static void main is that I'm going to call this familiar setup orders method that I've been using here in previous examples, and all it does is just create, I don't know, like 6 orders with a bunch of order items each. No big deal there. I have an order class defined, and you can see at the very bottom of the order class I have 2 methods I created. One is called sort by order amount, and the other one is sort by order date. Now these happen to have 2 input parameters, both accepting in 2 orders that will compare, and then it's going to return a Boolean, true or false, that, and essentially order amount for the first item passed in is less than order amount for the second item passed in. Is that true or false? Return that. Okay, they both have that same method signature, and let's see if I can find it here. Where did I define that? They are both instances, I guess you could say, of this delegate definition called sort comparer of type T. So T first item, T second item returns a bool. Notice that that is what I use in my definition for sort. I'm defining this delegate, this method signature, and then I'm going to expect that passed in, because then I'm going to use it whenever I actually do my comparisons and decide what should come in what order. This order, is it going to be higher up in ranking or in ordinal position than another order? And so I'm going to use these, and I'm going to demonstrate how we'll pass either of these in and sort by either the amount of sale or of the date of the order. Okay. All right, and then, well, we'll come to that a little bit later. In fact, let me just comment this out as a little unfortunate foreshadowing to the second part of my example. All right, so we're back to the static void main. Here I'm going to, first of all, sort by order amount. I'm going to call this bubble sort of type order. I'm going to pass in all of my orders that are returned from this setup orders method, and then I'm going to pass in a reference to my one method, sort by order amount. I made that static so I could just call it like that, right? I don't need an instance of order to do this. And so I'm going to pass in this method and say, when you're sorting orders, use this method as the criteria by which you sort all of the orders in the list. And then I'm going to create the exact same example, but this time instead of by order amount, I'm going to call that other method sort by order date, just to see how this all works. So let me run the application now, and you can see I've done a bubble sort from least to greatest based on the order amount. So you can see these are out of order. Here's the order ID. They're not ordered by order ID, and they're certainly not ordered by date, but they are ordered by the order amount. Then I rerun that same example, this time using the date as a criteria. So December 7th, 8th, 9th, and 10th. Okay, they happen to be in the same order as the ID. That was purely accidental, but certainly not ordered by order amount. Okay, so now just to show that the same example, the same sort algorithm works regardless of type, I created another class called utility, and simply as a container for another instance of the delegate. This time it's going to know how to sort integers, and so I'm going to pass in an integer and another integer, and I'm going to return a Boolean. Again, that will satisfy this generic delegate, or the generics that were defined in this delegate, to sort integers. And so way back here at the top in this code I commented out just a moment ago, here now I have a list of integers of type integer called my integers, and I've created a sequence of numbers that you might be familiar with, but I put them out of order. And now I'm going to pass in to my sort method of my static bubble sort class. I'm going to pass in that list of integers, and then I'm going to pass in the method. I'm passing in the method sort integer, and then I'll rip through all of them and display the results. In fact, let me go ahead. Well, I'll go ahead and run it just the way that it is. And you can see it sorts that sequence of numbers as we would expect. Okay. So what I want to do is stop there for this video. This is step 1 in a 3-step process. In the next video, we're going to simplify all of this delegate talk and move on to anonymous methods to see how we can simplify the notion of delegates and make it even more simple using less code to accomplish essentially the exact same functionality. But when you think delegate, you should think of a pointer to a method or pointer to a function that can be passed in or used just like any other variable or object. It can be passed around, and it can be used to delegate the responsibility of some calculation, of some algorithm, what have you, to another chunk of code that you'll pass in. You'll tell it what the criteria is. This becomes important in the whole link story, so don't discount this. Also, let me say this real quick in passing. Delegates up to this point have often been associated with events. Now, we haven't talked a lot about event-driven programming just yet. That's more of a topic when you get into building ASP.NET web form applications or ASP.NET Windows form applications. Whenever you have a button and you double-click the button and you write code in the button's click event for either web or WinForms, then you're essentially attaching a method to be called whenever that, or you're basically saying, this is my delegate signature for an event. Call this event. I'm going to pass this event, and you should be calling it whenever somebody clicks on the button. And you can see all that code wired up in your applications. And when we get to that point, I'll point that out. That'll be several, probably days, if not weeks from now. So hang on to that thought. But it's often used with events as well. Okay, anyway, take our knowledge of delegates, just let it roll around your head, and I'll see you in the next video when we talk about anonymous methods. Thank you.